All right, so graphing. Let's start with position time graphs. Position versus time. And we'll do two different options. Actually, we're going to do three different options. And we'll separate this out. Okay, so let's start with this. Our position versus time graph is a straight line. What does that mean if our position versus time graph is a straight line? What does the slope of a position versus time graph tell us? It tells us velocity. Okay? The slope here is the velocity. So if you have a position versus time graph that is a straight line, it's a straight line, then your velocity versus time graph has to be constant. It has to show a constant velocity. Constant slope gives me a constant velocity. So if this slope is positive, then we have to have a constant positive velocity. Some number that is some positive value, okay, and it has to remain at that value regardless of the unit of time. Right? If we're talking about the acceleration of this, what's the slope of a velocity versus time graph tell us? Yeah, this is acceleration. What's the slope of that line? 0. So is there an acceleration? No. So there is no acceleration. Now, this works for any velocity versus time graph that is a straight line. Okay, it could be a line that, it goes this way. It could be a straight line that goes down this way. It could be a straight line that starts from 0 and goes negative. It could be a straight line that starts negative and moves in a positive direction. It doesn't matter. It's irrelevant. If the position versus time graph is a straight line, then there is no acceleration. Okay? All right. So let's talk about if it's not a straight line. Okay? And again, we're going to do our happy face, frowny face, and I'm going to do it in colors. So let's do a happy face, first half that's red. We'll do a first half of the frowny face that's red. We'll do the second half of the smiley face green. The second half of the frowny face green. And then we're also going to do a blue line that's kind of underneath all of it. That's the entire smiley face. And we'll do a blue line underneath the other ones. That's an entire frowny face. And we will color code all of these so that we are 100% sure which graph corresponds with which graph. Okay. So, let's go ahead and split those down the middle here because we've got options. Over here, my velocity graphs can either be red, green, or blue, and then they'll correspond with those parts of our position time graphs. Does it make sense what I'm doing here, guys? Yes, no? Okay, so if we look at the red section, what is happening to the slope of that red line? Let's take a look up here. What is the slope initially here? Like if you were to draw a line tangent to that curve, and I'll use the marker to do it. Here's the beginning of that curve. Okay, if I were to draw a line tangent to it, it would only touch one point on that curve. How would you describe the slope of my pen in relationship to the line? Positive, negative, or zero? Positive, negative, or zero? Negative. What about now at a time further along the line? Still negative, but more or less negative? Less negative. And when you get down to the bottom, what is the slope there? Zero. So that means our velocity had to start at a negative value and move to zero. So I start at a negative value, and at some time we reach zero. And our velocity went from a large negative number to a smaller negative number to zero. Then where does the green line start? Yeah, this would start at a slope of, starts at zero, and now it becomes more positive and more positive. So if you're going to start here at zero, it's going to move to some positive number. It gets increasingly more positive. Well, and then what does the blue line really represent? Yeah, both of them put together. Starting with the red one, right? And then moving into the green one. So that means we would start from a slope that is negative all the way down there. And eventually we'd get to some positive value. Starts here negative, gets less negative, goes to zero, gets positive, gets more positive. Does that side make sense? Yeah. Okay. Let's check out this one. Where does the slope of the red line start? What type of value? Positive. Big positive? Little positive? It's a big positive, right? What happens, halfway through that motion? Less positive. What happens at the very end of the red line? It's zero. So we start positive and move to zero. What about at the green line? What type of slope does that one start with? Zero. Negative. More negative. So it starts here at zero. Goes negative. And what's the blue line? It's both of these together, right? So again, start positive, gets to zero, goes negative. So start positive, goes to zero, goes negative. Oh, that was good. I was off of my dot. No big deal. Okay. So those are all the velocity graph options, depending on whatever curve you have. And again, we don't do anything more than this for our graphing, so this is it. I mean, these are your options. Okay? If I've got this position versus time graph, that position versus time graph, or the whole darn thing, or this position time graph, that position time graph, or the whole darn thing, these are your 6 options for graphs. That's it. That's all they can be. Okay? Now here's the really nice thing then about the acceleration graphs. We only have 2 options for acceleration graphs if the motion is just one simple curve. Remember, the slope of a velocity versus time graph is the acceleration. So what kind of slope does this have? Positive or negative slope? Positive. What kind of slope is this? What kind of slope is that? All of these are positive, right? Remember, happy face means positive constant acceleration. What kind of slope is this? What kind of slope is that? What kind of slope is that? All of those are negative. Therefore, constant negative accelerations. Okay? So that's pretty much it, guys. I mean, there really isn't anything more to the graph translations other than understanding the connections that a position versus time graph, the slope tells you the velocity. For a velocity versus time graph, the slope tells you the acceleration. And then you have to be able to go, forward and backwards, go from here to here, or from here to here. And maybe going from here to here is the harder part, but if you look at, say, this velocity graph, if it starts at 0, if the velocity starts at 0, then what do we know that the slope on our position graph has to start at? 0. The slope of the position versus time graph would have to start at 0. And then if the value gets more negative, then the slope on your position versus time graph would also have to get more negative. So it's going to look like this. That green half starts with a slope of 0 up here, and then gradually becomes more and more negative with the slope. Now, the only thing that these velocity graphs will never tell you is where to start your position versus time graph. But does it matter? It doesn't matter. Okay, unless the problem or we tell you start from this position. Okay? Hopefully that clears everything up with graphing. Okay?